Hey, welcome to Trig Functions Part 2. And I'm going to start with an example here and show you how that cast rule stuff just might be very important to help us answer some questions. So, here's the clues that we're going to give you. We're in quadrant 3. Okay, I know I'm in quadrant 3, and another clue is that cosine of theta is negative 5/13. So you go, okay. Now what we want to do is we want to figure out what is sine theta and tan theta. Okay, so that's what we got to determine. Now, with all these questions, I find a picture really helps. That's the first thing I'm going to do, is I'm going to draw myself just a simple little grid over here, and I'm going to try to put in all the information that's given to us. So we're in quadrant 3, so 1, 2, 3. So we're down here, and it says the cosine of theta is negative 5/13. So let's just draw any old terminal arm. Okay, there's my terminal arm. And what I'm going to do, theta technically, yes, goes like that. But I'm going to build our little triangle here. Okay? And in our little right triangle, I'm going to use this information of cos theta is negative 5/13. And I'm going to label the sides that I can in my little triangle. Now, cosine is the adjacent side, so this would be the negative 5. And you notice it matches our picture. We've gone negative here. Hypotenuse is always positive. Okay, so there we go. I got two of the sides of my triangle. I'm going to use Pythagoras to figure out this missing side over here. So I'm going to go hypotenuse squared equals negative 5 squared plus this unknown side squared. So let's square out these numbers. So I get 169 equals 25 plus the unknown side squared. We're going to subtract 25 from both sides, so we get 144. And then, of course, I will square root both sides, so I get basically 12. And I say basically because I'm going to tweak that. When I go to my little drawing over here, when I label this side as 12, well, according to this drawing, we kind of went in a negative y direction. So I'm actually going to label it as negative 12. When I do that, it saves me the trouble of having to remember the cast rule. It's kind of like you're already doing the stuff from that cast rule. Although, I still like to throw it in there to kind of make sure I didn't mess up. So it's really doing it two different ways here. So I'm totally ready now to label and say, I know what sine theta is. Here's my reference angle. The sine would be negative 12/13. Okay, and the cast rule confirms that. Okay, it says the only thing that's supposed to be positive in this quadrant is tangent. So we have a negative cosine, we have a negative sine, and the tangent, well, it's going to be negative 12/negative 5, which is positive. Again, matches the cast rule. Okay, so there it is. There's my answer. Not too bad, but I can't emphasize it enough. Get yourself a drawing. It really helps to make sense of these type questions. All right, let's do another example. Okay, next question says that this point here, 5, negative 7, is on the terminal arm. Okay, is on the terminal arm of theta. Okay, so it's on the terminal arm, and we want to try and determine or find cos theta. My theta isn't too, anyway, it's good enough. Well, I'm going to get a picture. Yet again, I find if I don't draw it, I have very little to work with. So let's plot this point. It's 5 to the right and then down 7. So it might be down here somewhere. And it's on the terminal arm. So let's see if we can draw a half-decent terminal arm there. All right. So theta basically is what they're telling me is this. All right. Well, let's use our reference angle, and let's build ourselves a little triangle here. Okay, so my little right triangle. And what do I know in this little right triangle? Well, I know this is the point 5 to the right, so that would be positive 5, and then we've slipped down 7, so negative 7. To get the hypotenuse, I'm going to use my old buddy Pythagoras' theorem. So I've got hypotenuse squared equals 5 squared plus negative 7 squared. So hypotenuse squared equals 25 plus 49. So hypotenuse squared equals 74. So that means the hypotenuse is the square root of 74. All right, so this is root 74. A little squishy there, but there it is. Now, it's really easy for me to determine the cosine of theta. All I got to do is say, well, here's my reference angle. The cosine is the adjacent side over the hypotenuse. And it looks like it's going to be positive. Maybe it's not a bad idea to use the cast rule and confirm that. So if I use the cast rule, oh, look at that. Cosine is positive in the quadrant that we're in. So there it is. Totally happy. And we've got our answer. Okay. So let's see if we've got enough time for another example. And you know what? I'm going to stop. Let's not make this too long. We're going to stop there and come back with another example.